From the very moment humanity first looked to the sky, the stars have been a source of fascination, mystery, and inspiration. For millennia, we gazed up at these distant worlds, wondering if we could ever reach them. Could we, in some distant future, break free from the bonds of our solar system, explore the great expanse of the galaxy, and perhaps even touch the stars? In the early days of space exploration, humanity's reach was limited to our closest celestial neighbors, the Moon, the planets of our solar system. But the great void that separates us from the nearest stars seemed insurmountable, an unreachable distance that would take thousands of years to cross with our current technology. The dream of interstellar travel, of crossing these vast distances, seemed far beyond our grasp. Yet, there is hope. There is a possibility that one day, we could achieve what once seemed impossible. That hope rests in the boldest of ideas, warp drive. The concept of warp drive has captivated us for generations. In the realm of science fiction, it's been a staple of stories for decades. From the fictional starships of Star Trek to countless other tales, the warp drive represents humanity's quest to transcend the limits of time and space. Yet, unlike many science fiction concepts, warp drive isn't just fantasy. It's grounded in the very fabric of modern physics, an idea that stretches the limits of our understanding of the universe itself. While warp drive has remained mostly within the realm of imagination for years, it's based on real scientific principles. The key to understanding warp drive lies in the theory of relativity, developed by Albert Einstein in the early 20th century. Einstein forever changed how we view the universe, showing us that space and time are not fixed. Instead, they are a malleable, interconnected fabric that can bend and stretch under the influence of mass and energy. For centuries, the idea of faster-than-light travel seemed impossible. Nothing, according to Einstein's theory, could surpass the speed of light. But what if the problem wasn't with the spacecraft itself, but with the very nature of space-time itself? The most revolutionary aspect of Einstein's theory was that space and time could be distorted. Massive objects like planets and stars warp the fabric of space-time, bending light and even time itself around them. In essence, space is not an immutable backdrop. It's something that can stretch, compress, and twist. This idea opened the door to a radical possibility. What if we could manipulate space-time in such a way that it would allow us to travel faster than light? In 1994, physicist Miguel Alcubierre proposed a bold new concept that would forever change how we think about space travel. Instead of propelling a spacecraft through space at faster-than-light speeds, what if we could manipulate space itself? What if we could create a warp bubble around a spacecraft, contracting space in front of it while expanding it behind? This theoretical approach would allow the spacecraft to remain inside the bubble, effectively being carried along by the stretching and contracting of space-time, while never breaking the cosmic speed limit. In this bubble, the spacecraft would move faster than light, without technically violating the laws of physics. To picture this, imagine the spacecraft at the center of a bubble, its position unchanged, unaffected by the speed of light that governs everything else. As the bubble moves, it stretches and contracts space around it. The spacecraft isn't moving through space. Rather, it's riding a wave of space-time itself, bypassing the limitations that usually apply to anything traveling within it. This is warp drive in its purest form, a profound, yet elegantly simple solution to one of the greatest challenges in space exploration. But with any new scientific breakthrough, there are questions that must be answered, and warp drive is no exception. How do we create such a warp bubble? And more importantly, how do we power it? To generate a warp bubble, we would need an incredible amount of energy, an amount that is far beyond our current capabilities. According to Alcubierre's original theory, the energy required would be equivalent to the mass energy of an entire planet. In fact, it's been suggested that we would need an amount of energy on the scale of Jupiter itself to create the necessary warp bubble. But that's not the only challenge. The concept of warp drive also relies on something called exotic matter. Exotic matter is a hypothetical form of matter with negative energy density. This negative energy is crucial for stabilizing the warp bubble and preventing it from collapsing, but as of now, exotic matter is purely theoretical. No one has been able to produce it in the quantities necessary to power a warp drive. Yet despite the seemingly insurmountable obstacles, scientists aren't giving up on the idea of warp drive. In fact, many researchers around the world are exploring potential ways to make this concept a reality. Some are investigating quantum fields, which exist at the smallest scales of the universe, as a possible source of the exotic matter needed for a warp bubble. We're also beginning to probe deeper into the nature of space-time itself. Some theories suggest that manipulating the quantum vacuum, the very fabric of the universe at its smallest scale, could provide the necessary conditions to create a warp bubble. Though these ideas are still in the early stages, they suggest that the road to warp drive might be more achievable than we once thought. So, what would it mean for humanity if we were able to harness warp drive? Imagine the possibilities. With warp drive, we could embark on interstellar journeys to stars and planets that were once unimaginable destinations. The closest star to our solar system, Proxima Centauri, is over 4 light-years away. Under current technology, a journey to Proxima would take tens of thousands of years. But with a warp drive, that same trip could be completed in just a few days or even hours. This wouldn't just be a technical achievement, it would be a transformative moment in the history of humankind. It would open the gates to a new era of space exploration, allowing us to explore the unknown, visit distant planets, and potentially make contact with other civilizations, if they exist. This future isn't as far off as we may think. While we're still in the very early stages of understanding warp drive, researchers are beginning to make important strides in the field. Advances in quantum mechanics, energy production, and our understanding of the fundamental forces of the universe could eventually lead to the breakthrough that allows us to travel faster than light. The road ahead is long, and the challenges are immense. But the very idea that warp drive could one day become a reality is a testament to the boundless curiosity and determination of humankind. It represents the pursuit of the impossible, the willingness to push beyond the boundaries of what we know and venture into the great unknown. In the future, humanity could step onto ships powered by warp drive, embarking on journeys that span entire star systems. Spaceports on distant planets could become as common as airports are today. Humanity would no longer be confined to one small corner of the galaxy. We would be citizens of the stars, exploring, discovering, and expanding the reach of our civilization across the cosmos. Yet, the greatest question remains, why? Why pursue such an audacious goal? Perhaps the answer lies in our innate desire to explore, to reach out and touch the unknown. Perhaps it's the same instinct that has driven explorers to sail across oceans, climb mountains, and venture to the moon. It's the urge to see what lies beyond, to discover new frontiers, and to understand our place in the grand, infinite universe.